Okay, so here's the family number groups in red, blue and black. They're all separated by 3, and there'll never be 2 in the same horizontal row, always polarized. So it's like 2 wires almost. These are the family number groups: 147, 258, 369. This doubling circuit shows 1 octave, or except it's not an octave, it's a, well, sort of is, but we could call it a resolution. Now, 1 resolution of a doubling is all the way through 1, 2, 3, 1, 2, 4, 8, 7, 5 along the dark rail, and without compressing, you can see it goes to 16 there, which will compress to 7. This would be a 32, which equals 5, and double that is 64. Now, 64 is important when you have a look at Nazim-Harameyn's 64 tetrahedron grid, which is the structure of the vacuum. And so it represents 1 resolution, just as Nazim's geometry does. 64 is an 8 by 8, so it's a square 8. And 8 is sort of the master number of everything except 9. If you separate 9, 9 is the 9 spine. So you're dealing with 8 numbers. Except it skips the 6 and 3s. They're like mini 9s. And even the number 8 is showing you this infinite loop. And surprise, surprise, it's exactly the same shape as this is actually doing. It's like light bouncing around inside a glass sphere. Here's the 64 tetrahedron grid, which is a vector equilibrium and a star tetrahedron. Creates perfect equilibrium and can be spun to make a perfect sphere. And when it spins, it has this vorticular dynamics, because it's not a stationary thing, always in motion. And it feeds its outer part to its inner part, and its inner part to its outer part. You can see that there's a small vector equilibrium in the center, and then there's a larger one over the top. So this is expressing a full resolution of time-space. In this flower of life lattice, known in sacred geometry, is actually 3-dimensional, and this is basically the 64 tetrahedron grid ratios. It's a fractal web matrix. This is the geometry of the matrix. And this is the mathematics of the matrix. It's very small bits of it, just showing you what it's trying to express. The vector equilibrium is a 3-dimensional one of these. It's got the exact same length to the middle as it is to its sides. Here's the vortex. There's always another side, and that side would be going out and back up into this side, so that it's perpetual. There's the black hole, there's the white hole. but it's one whole system, and it's all being driven by the center. There's a 9, call that 3 or 6, oscillation, positive and negative. 3, 6 and 9 overlaid just to show you the symmetry that it's even telling you just in the shape of the numbers themselves. It's a black 3, red 6 and a blue 9. And notice it creates like a big 8. The 8, as we saw before, is a resolution which is defining a cycle. But it's an infinite cycle, and it has all those numbers. The ones that are left out of those, the 3, 6s and 9s, are an infinite constant. They're both infinite, but one's closed and one's open, or whichever way you want to look at it. One's truly infinite and the other one's infinite cycles, so it has beginnings and ends. So that's the 3, 6, 9s. The 1, 2, 4, 8, 7, 5s, the actual digits have a sort of mirroring also. And this is exactly how they are over here on the large grid. 1, 1, 2, 5, 4, 7, 8, 8. So 1 and 1 obviously mirror each other. I mean, it's 2 lines. The 8 and 8, they mirror each other perfectly. Either way. And 1 and 8 mirror opposites. And then you got 2 and 5, which are like mirror inversions, and 4 and 7, which also are mirror inversions, except that 4 has a line through it. So it's saying something about there's a little bit of difference about 7, and we'll get to that later. 7 is the enneagram, which gives a decimal count of these same numbers in a different order.